All right, here's our third video from section 6.3. And so far, all the problems that we've added and subtracted have already had common denominators, but eventually they won't. So let's talk a little bit about how to find a common denominator, or at least common multiple. If you remember, back in the day, when we subtracted fractions that didn't have common denominators, we had to make our fractions have common denominators before we could combine them. So for example, if I had a 2/3 minus 1/4, I couldn't subtract them yet until they had common denominators. So I had to figure out what the common denominator was. What number does 3 go into and 4 go into? We can make them both 12s, right? But if I multiplied the 3 by 4 to make it into a 12, I also had to do the numerator. I had to keep them balanced. If I wanted to make that 4 into a 12, I could multiply both the numerator and the denominator by 3. As long as I did it to both the numerator and denominator, my fractions were balanced. That gave me the first fraction of 2/3 into an 8/12, right? If I took 8/12 and reduced it, it would give me 2/3. It's just a bigger version of itself with a denominator of 12. When I took the 1/4 and multiplied the numerator and denominator by 3, I ended up getting 3/12. Again, if you reduce 3/12, you should end up getting 1/4, right? It's equivalent. It's just a bigger version of itself with a common denominator now. And now that I have a common denominator, 8/12 minus 3/12 can really be combined into a 5/12. I keep the common denominator, I just add or subtract the numerators. Now, that same thing works with rational expressions. If I have a 2x and an 8 as my denominators, I can't combine these two fractions yet until they have the same denominator. So I need to figure out what coefficients I need to have and what variables I need so that they all have the same stuff, the same denominator. So I need to make that 2 into an 8. I can multiply both the top and the bottom by 4. If you notice that this first fraction, though, also had an x next to it, which the 8 doesn't. So the 8 also needs an x. As long as I do it to the bottom, I have to make sure that I do it to the top to keep those balanced. So that first fraction turns into a 20 over 8x, equivalent to its original version, 5 over 2x. It's just a bigger version of itself with that common denominator. If you look at my second fraction now, the numerator is now a 3x and my denominator is an 8x. And now that they have a common denominator, I should be able to add them together, keeping my common denominator and just adding my numerators together. Now, if there was a common factor between all three terms, then I can reduce it, but it doesn't look like there is. So that would be my final answer on that one. Getting common denominators is a little bit harder, right? So let's practice a little bit finding that least common denominator. Making sure all our denominators are factored completely so we can figure out what factors we have in each so we can get them all to have the same factors eventually. We're going to look at monomials first and include the smallest number of the coefficient that the coefficient divides into, and then variables and their largest exponent. The LCD will also include one of each binomial. Let me show you what that means. If you look at example number 3, if it asks us to find the LCD, the least common denominator. If these are my two fractions, what I want to do is I want to figure out what factors are in my denominator. So if my denominator on that first fraction is a 36 and an x squared, I want to try to break that down into factors of 36 and factors of x squared. I'm going to do the same thing with the second fraction, figure out what factors make up 24 and x. And then I can make sure that both my denominators have the same factors or a common denominator. So I'm going to look at that 36 and I'm going to factor tree. I'm going to break it down into prime factors. So I know 3 goes into 36 12 times. I know that 12 can be broken into 3 times 4, and 4 can be broken into 2 times 2. So really, I have 3, 3, 2, 2. 3 times 3 times 2 times 2 give me 36. Those are the factors of 36. My x squared is also just x times x. So again, I have 3 times 3 times 2 times 2 times x is really just a broken down version of 36x squared. I'm going to do the same thing with my second fraction. I'm going to break down 24x and see what factors make it up. And then I can compare the two and make sure they have the same stuff, the same factors. 24 breaks down into 2 and 12. 12 breaks down into 2 and 6 breaks down into 2 and 3. 2 times 2 times 2 times 3 are the prime factors of 24. And then remember, I also have an x. Now let's compare. The first one has 2 3s in it, but the second one only has 1 3. So in order to get them to be common, they both need 2. So the second one would need another one so that it has 2. If you notice that the second one had 3 2's, but the first one only had 2, that means it needs another one so it can have 3 2's. 2 3's and 3 2's. So they all have the same factors. You notice that this first one also had 2 x's, but the second one didn't. It only had 1. So we need another x so it can have the same factors, or common factors. So if they both have 2 3's, 3 2's, and 2 x's, 3 2's, 2 3's, and 2 x's, 2 times 2 times 2 times 3 times 3 really is 72, and then I have an x squared. My common denominator would then be 72x squared. I would need them both to turn into 72x squared so they can be common denominators before I added or subtracted these two fractions together. So I broke it down to find all the factors, and then they all needed common factors. So whatever the first one didn't have, the second one did, we put it there, we multiplied by. Whatever the second one didn't have that the first one did, we had to give him it. So they all had common factors. We'll keep practicing as we go through the next videos. Let's look at example number 4. We'll do A and B now, and then we'll do the next video for the rest of them. Find the least common multiple. Same idea as a common denominator. We want everybody to have the same factors. So let's take 15a and 35b and break them down into factors. 15 breaks down into 3 times 5 times the a. 35 breaks down into 5 times 7 times the b. And if we all want them to have the same factors, the first one has a 3 and a 5, but what is he missing? It looks like he's missing a 7, so we would have to multiply by a 7. The second one has a 5 and a 7, but it looks like he's missing a 3, right? Now they both have 3's, they both have 5's, and they both have 7's. Now the first one has an A, but not a B, so he would need a B. The second one has a B, but not an A, so he would need an A. Now they have the same factors. They both have a 3, they both have a 5, they both have a 7, they both have an A, and they both have a B. If I gave them the same factors, then together that common factor, that least common multiple, would be 7 times 3 times 5, which is 105, and an AB. So their common multiple, or common denominator, if these were denominators, would be 105AB. Let's do one more. I have 21x cubed y to the 6th, and then 7x to the 5th y squared. Let's break them down into factors, and let's make sure everybody has the same stuff, the same factors. All right, 21 breaks down into 3 times 7, and then I have an x cubed, 3 x's, and a y to the 6, 6 y's. You can write them all out if you need to. The second one has a 7, it has 5 x's, and only 2 y's. If they need all the same factors, what does the first one need that the second one has? Well, it looks like it already has a 7. This first one has a 7, and the second one has a 7. Those are already common. But it looks like he has a 3, the first one does. The second one's missing a 3, so we would need to make sure that we give him a 3. You also notice that the first one had 3 x's, but the second one has 5, so he needs 2 more in order to have the same amount, the same factors. But you also notice that the second one only has 2 y's, and he really needs 6 to be equal to the first term. And so he needs 4 more. Whoop, what happened? Where did we go? Sorry about that. So he would need a 3 and y to the 4th. So if they now have the same factors, they both have 3's, they both have 7's. If I multiply that gives me 21. They both have 5 x's, that's x to the 5th, and they both have 6 y's, that's y to the 6th. So the least common multiple, or if they were common denominators, would be 21 x to the 5th, y to the 6th. Kind of tricky. Keep practicing though. We'll do some more examples here in the next video to get you stronger with finding those common multiples, so that way when we have to apply it to common denominators, we're really good at it.